Number 7, exercise 2.1. The question is, first part of this question is, A is a matrix having elements 2, -1, 3 and 2, and to calculate the inverse of the matrix A. For the inverse of a matrix, the first condition is when the matrix is a square matrix. So the order of this matrix is 2 cross 2, so matrix A is square matrix. And the second condition for the calculation of inverse of the matrix A is that the matrix A is non-singular matrix. For the non-singular matrix, we have to check the determinant of the matrix A. The determinant of the matrix A is 4 minus 3, which is equal to 7, which is not equal to 0. So the matrix A is non-singular. Therefore, A inverse is exist. For the inverse of a matrix, first we have to calculate the cofactor of each element of the matrix A. The cofactor of the element of the element in the first row and first column of the matrix A is -1 raised to power 1 plus 1. This element is in the first row and first column. Multiply by delete the first row and first column, we get 2. Multiply 2 with the -1 raised to power 2, we get 2. Calculate A12, the element, the cofactor of the element in the first row and second column, which is equal to -1 raised to power 1 plus 2 multiplied by 3. 1, delete first row and second column, we get 3, which is equal to -3. Similarly, calculate the cofactor of the element in the second row and first column, A21, -1 raised to power 2 plus 1, delete the second row and first column. After the simplification, we get -1. After the simplification, we get 1. Calculate A22, the element, the cofactor of the second row and second column. The cofactor of the element of the second row and second column is -1 raised to power 2 plus 2. Delete the second row and second column, we get 2. Multiply with 2. Multiply this element with 2, we get 2. Replace the element first by its cofactor, the element second by its cofactor, the element third by its cofactor, and the fourth element, the last element, by its cofactor. We get another matrix. Denote that matrix by B. Taking the transpose of the matrix B, transfer the first row with first column, second row to second column. This matrix is equal to adjoint of the matrix A. Transfer the first row to the first column, second row to the second column. Now, for the we have to apply the formula for the calculation of the inverse of the matrix A, which is A inverse is equal to 1 divided by determinant of A multiplied by adjoint of A. Determinant of A is equal to 7, 1 over 7, and adjoint of A is a matrix having elements 2, 1, -3 and 2. Multiply each element of this matrix by by a scalar 1 over 7. 2 multiplied by 1 over 7 plus multiply 1 multiplied by 1 over 7, -3 multiplied by 1 over 7, and 2 multiplied by 1 over 7. We get this matrix, which is the inverse of the matrix A.